Hi, I'm Brooke, and I'm going to show you how to implement a insert method for a binary tree. I'm also going to teach you how to create the binary tree itself and create a class that refers to the nodes in the tree. So start off, we're going to actually create the node, and it's going to refer to these little circles here. Like, these are nodes. One thing to note about binary trees is that these are referred to nodes and these are referred to as edges. So we can traverse from one node to another by using these edges. We're not really going to get into that today. We're just going to show you how to create one and create an insert function so you can actually put a node into its place. And something else to note about a binary tree is that the way it's structured is it first just determines, you start out here with the root node, and then all of the further down we go in the tree, which are more like roots, honestly, but the further down we go, the more children it has. So, like, every node down here is a child of this root node. And we also call nodes that have children parent nodes. So this would be a parent node to this node 4 and this node 5. But this would not be a parent node. This would just be a child because it doesn't have any more nodes connected to it. So anyway, we're going to go ahead and create our class, and we can just call it node. And this is what we're going to refer to when we're talking about a node. So let's first talk about what we're going to refer to when we're inserting into the actual tree itself. We want to specify whether it's a right or a left node. So the first thing we would have to do is determine whether or not it's a right or a left node and whether or not we need to insert it on the right or left. So we do need to set some variables that refer to either the right or the left. And then we also need a variable that refers to the data that we are also trying to insert. So we would just define, first we would define an initialization class. Init usually just pops up, but we just want to take in data. And then we want to we want to refer to the left node, we want to be able to refer to the right node, and we want to be able to refer to the actual data that node houses. So we can say like self.right equals, and we'll start with none, so it doesn't have any data yet. Self.left is also going to equal none, still no data, and then any data that we're referring to is going to be known as self.data, and that refers to the data that we're going to use from the insert method. Or whenever we initialize a node, this is the data that it's going to refer to, and it's going to set that data. Cool. So we have our initialize function. Now we want to have an insert function. But before we do that, we can also just create a function that will print out the actual nodes itself. If we don't have anything, we can create, we can just create it as a placeholder for now. We can say like print tree. Oops. It's so hard to talk and type. And then we can just print the data. So once we call this, if we want to create a new node, we can just say like the root is equal to node, and let's say we have a node that is, the only value right now we have is 10. We don't have any way to insert, we don't have a function that's going to insert any data, but we can define the root of our node, and define the root of our tree by creating a node with value 10. So if we print that out, we can just call the root.printTree function. So once we run it, we get 10. It doesn't really have anything in it. We don't have an insert function. But now we know that initializing our first node as our and defining it as our root works. So let's create an insert function. Let's say we want to have something between both of these calls, like between defining the root and actually printing the entire tree. Let's say we want to actually like put something in the tree. We're going to define an insert node function, and it's going to take in the data that we are referring to. So whatever data we want to insert, we want to make sure we take that in. So the first thing we need to think about is if the root node exists. So we just started off creating a node, and we want to see if the actual data itself exists yet, like if we have anything at all. So if the root node exists, is going to be our first conditional. Otherwise, if the root node does not exist, we want to just set the data that we have here as our root node. So the first thing we would do is just say like if self.data, and then here this just checks to see if the data itself exists, and we can do like a pass right here. Otherwise, we just want the self.data to equal the data. Cool. But now we need to fill in this function. We need to fill in the actual function to see if we need to insert the data into the left or the left or the right side of our current node. So the first thing we need to check is if the data is less than the self.data, the data that we're comparing it to. So if the data is less than the self.data, and then the second conditional we need to think of, let's just pass for now. The second conditional we need to think of is if the data is greater than the self.data. So these two conditionals, and we'll go ahead and pass here too. These two conditionals, if the data is less than the self.data, then we are going to insert it into the left side. If it's greater than the self.data, we're going to insert it into the right side. So I'll just put that right here. So insert into the left side, and then insert into the right side. Cool. So we can start off by sort of figuring out what conditionals we need to insert it into the left side. So we're checking to see if it's less than the self.data. Cool. Now we know we need to insert it into the left side. But there's one more thing we need to check, and we need to check to see if there is a left value. So the first thing we need to check is to see if there is or is not a node already in the left category. So we need to check to see if the left node already exists or not. So we can say like if self.left cannot type is none. Then we want to just create a new node. So we didn't find a left node, we just want to create a new one because we already passed the conditional, like the data exists, we already have one node, it's less than it, and it doesn't have a child. So we want to create a new node off of that child, in which case we can just say that the new left is going to be a new node with the given data. Otherwise, we want to recursively call on self.left the insert node function with the data that we have. So when we recursively call it, we're going through again with the self.left data, with the left-hand data we have, with the value that we're still trying to put inside of the actual tree, and we're going to do the whole thing over again, essentially. So we would just call it self.left, call the function insert node with the data we have, And then that should be pretty much it. So we check to see if the node exists. If it didn't, then we would create a whole new node, and if it did, then we would call the function again with the self.left value. Cool. And if we want to insert it into the right side, we would literally do the exact same thing. We would not pass, but we would check to see if it actually exists. If self.right is none, then we create a new node with the data. I could copy and paste, but I like typing. Otherwise, we call right. We use right to call the insert node function with our given data. And that's pretty much it. That is our insert function. We just check to see, to recap. Oh, and this should be an elif. This should not be an if. Sorry about that. So we check to see, just to recap, if the data exists, do all of this, insert a node somewhere. Otherwise, we just create a new node. We set the current data to the actual data that we have, which basically creates the root. Otherwise, we insert it into the left side if it's less than what we already have. If it's greater than what we already have, insert it into the right side. And then we just see if we need to create a new node because the node doesn't yet exist, or if we need to recursively call insert node to traverse the tree again and see where it needs to be put on whether it needs to be put on the left or right of this new current node that we're looking at. And that's it. That's pretty much how you would create an insert function. And now we can modify, we'll have to modify this print tree function in order to print out the left and right values of the tree. So let's first see, we basically need to check to see if the left and right values exist, and then we can print them. So if self.left exists, then we do self.left .print tree, call that recursively again. So we print everything on the left side, and then we can go ahead and do the same thing for the right side. Goodness. Okay, so now we've modified our print tree. We have our insert function. Now we can call it a couple times. So say we want to insert a couple of values. Let's try like root.insert node, and let's do 3, and let's do this a couple more times. And let's say like 4, 6, 2, 12, and let's do a 5. So it's not in any particular order, but once we run it, we can see the first node we had was 10. That was our root, and then we inserted a bunch more nodes, and now we're going to print it out to get our binary tree with all the nodes added in order, which is super cool. So we did that correctly. We were able to create a node class with left and right nodes with the assigned data to each node, an insert function, a print function, and we were able to create a root for our tree, along with inserting a bunch of nodes and printing that out. And we were able to do that successfully and in order. Wonderful. So there are many different things that you can do with this. You can learn how to delete a particular, you can create a function that will delete a particular node, maybe even move a node, traverse the tree. It is important to note that if you want to traverse the tree, you can't, and you want to create a function for that, you can't randomly access a node in a tree, so you have to traverse it, which is a very popular way to get data from a binary tree. And there's 3 ways to do that, which I'll talk about in a different video, but I hope that this was helpful and you learned how to insert a node into a binary tree. All right, thanks for watching. I'll see ya.